Okay, welcome back. Okay, so I'm going to summarize everything I've talked about, and so again, this is kind of repeating, but it's good to see it again and put it in your notes. So I'm going to read, I'm going to fill in some things, and then just add to your notes accordingly. So for rational functions, remember, for a rational function given in this form, where a sub n and b sub n are not equal to 0, then we either have 1, the degree of the numerator and the denominator are the same, which tells us that there is a horizontal asymptote at the ratio of the leading coefficients, a sub n over b sub n, as x approaches plus or minus infinity. Case number 2 is if the degree of the numerator is less than the degree of the denominator, then in that case you have a horizontal asymptote at the y equals 0 line, or the x-axis, as x approaches plus or minus infinity. And then number 3 says, well, if the degree of the numerator is greater than the degree of the denominator, then what happens is there is no horizontal asymptote, and f goes to either positive or negative infinity depending on the sign of the depending on the sign, right? So you have to look and consider what's going on as you go to either positive infinity or if you go to negative infinity. So this is the one you have to be careful, because whether it goes to negative infinity or positive infinity, it depends on the signs of the top and the bottom. Okay. Also, if the degree of the top is exactly one more than the degree of the bottom, then you have an oblique asymptote. Okay? And you know that it's going to get closer to that oblique asymptote as x goes to positive or negative infinity. Okay? And again, you got to watch the signs and analyze this a little bit further, okay, to make sure that you get the correct limit. Okay? So that's it. Now we're going to turn our attention to functions involving radicals. Have a great day.